All right, let's start again with the second part. So let's get back to this issue of what happens if the name node crashes. The first thing we saw is among the three things that the name node is responsible of, we back up the first two, but we do not back up the third one, which is the locations of the blocks, because this is something we can recover from the heartbeats and the reports. All right. So if at a certain point in time we want to back things up, we just take a snapshot. That's pretty much what you do with your laptop as well, right? Who does a backup? I already asked you, I think. Very good. So you take a snapshot and then you make a copy at a certain point in time, right? But here's the problem. Just like your laptop, the cluster has a life. Files will keep getting created and directories created, modified, and so on and so on. So that means that we have to also back up the evolution of the cluster. But it would be very inefficient if every time we take a full snapshot. So it's easier if we just have some log that just has the differences. We just keep track, okay, we created this, we created that, we modified that. And we just, like a journal, we just have a list ordered by time, you know, in what was done. It's an edit log. All right. And with this, so it's growing, of course, the more you do, the more the edit log grows. And then you back it up to Glacier, which is S3, for example, the cheap one with high latency and so on, backup drive, shared drive. So all you can just back that up. All right. In addition to the network attached drive on which it is, I mean, plenty of copies. I can't have enough copies. All right. So now if it fails, we need to start it up again. So what that means is it's crashed, so we have nothing left in memory. It's a total disaster. And then we look at the network attached drive where we actually made this namespace file and edit log. So we have a backup. Now we are happy. We have a backup. So what do? We take the namespace file first, and we copy over the entire file namespace and the mapping from the files to the block. What do we do with the edit log? We play it. It's like, who is a musician? Do we have musicians? No musicians? Who plays on instruments? Oh, I'm surprised. Right, maybe you're too shy to say it. Anyway, there is a file format for musicians that's called the MIDI file, M-I-D-I. And this is actually an edit log of playing music. So when you have a MIDI file, you can actually, it contains instructions that at this moment you play that sound, at this moment you play that sound. So this is pretty much like a music file, except that instead of music, it's just changes to the log. So you play the edit log, literally you play it, I put this triangle there, and it's just going to play the changes on what you obtained from the namespace file, right? So you play it, and it's going to add more things that were done after the namespace file was created. The block locations, we didn't save them, but that's fine. We just wait until the data nodes connect to the name node, and they will report their blocks, and then we have the locations, right? That's it. How much time does it take? Easily half an hour. So you're basically, you have a downtime of 30 minutes every time the name node crashes. Now, this is to put in connection with the service level agreements that we saw last week, these 99.99999. It's the promises you make, but it might be that the contract that you have says that it's not okay to be down for 30 minutes, even in a year, right? So that might not be okay. So we need something better. Can we do better? Of course, the answer is yes, we can do better. Otherwise, I wouldn't ask. One of the ways you can do it better is that if the edit log grows too large, then you compact it back to a single namespace file. So regularly, that's called a checkpoint. You just recreate a new namespace file, and then you start again with an empty edit log, right? Okay, so this is one way. There is another way, is to have vice name nodes, so to say, to basically have other machines that help the name node. So what they do is they mirror everything. They keep track of the file namespace, the mapping from file to block IDs, and so on. They keep track of everything in the shadow, right? They just have a copy of everything that the name node has. That's called the standby name node. And what happens is that if the name node fails, instead of restarting and waiting for 30 minutes, the standby name node takes over instantly, just jumps in, Why is it so fast? Because it already has all the information. It was keeping track of it at the same time. So its only job is to jump in and replace the name node spontaneously if this is needed. Now, if you look at documentation or old slides or all the older books, because this is evolving very fast, you might read not only about standby name nodes, but you might also read about checkpoint name nodes, about backup name nodes, about secondary name nodes, and so on. And then you might wonder, what is all of this? Why do I have to know all of this? Well, you don't. This is what I consider to be archaeology, right? Year after year, they improved the system and came up with a new name for what they were doing. The latest name that I'm aware of is standby name node. So checkpoint name node, backup name node, secondary name node, forget about it. You can just consider its history. It was just previous versions of standby name nodes. All right? But there is a new one that is actually interesting mentioning, and that's the only one that I'm going to mention. It's observer name node. What does it do? Well, it's just like the standby name node, except that it can jump in to help even if the name node doesn't crash. It can jump in to facilitate read requests, meaning that the observer name node is not going to make any changes. It's not going to accept deleting files, deleting directories, changing, renaming. That it doesn't do. But just reading, it just helps out, right? If there are suddenly many people using the HDFS cluster who want to read files and the name node is overloaded, then the observer name nodes are just going to help out by also answering client requests with the block and block location so that the clients can read the data, right? It's like you're in the supermarket and you open a new cashier desk for payments, all right? For whom is that clear? All right, so you only need to know about these two, right? The standby and observer that just in addition can also serve read requests. Okay. This is also something cool. It's been a while now, but basically you can also have multiple name nodes. And the way you do that is similar to what you do when you install Linux. So I don't know, now it's pretty easy to install Ubuntu and so on. So it just works. But in the early days of Linux, you also had to partition your hard drive by saying, okay, my home, so the home files, they are on that partition of the hard drive. The system files, they are on that other partition. The swap is on this other partition. We can kind of do the same thing with HDFS. We can also say that the name node on the left is only responsible for the files that are in the directory foo. And the name node on the right is only responsible for the files in directory bar. And maybe a third one for the rest, right? This is called the federated distributed file system. It's the Switzerland of distributed file systems, right? You just distribute over the responsibilities for the file hierarchy, and then you can have multiple name nodes, right? Does it make sense? For whom does that make sense? Okay, that's called the federated distributed file system. Okay, now, finally, I'm done with the implementation and so on. How do you use HDFS? Well, of course, we're going to use it with MapReduce and Spark in a few weeks. That's actually the coolest way of using it. But you can still use it without MapReduce and Spark. Then you can upload, download. I mean, you can do that. So that you can do on your command line. The command line, it's this terminal window that you can open and type commands in. And there is a command that's called Hadoop FS for file system followed by arguments, right? You might also see HDFS DFS, which does the same thing. What's the difference between the two? Hadoop FS works with other systems, not only HDFS. Hadoop FS will also work with S3. Yes, the S3 we saw last week. You can also work with S3, with blob storage, with the local file system, and so on. So if you have to use one command, just use Hadoop FS. That way you know it will work on all file systems. Okay. Now, how does Hadoop FS work? Well, I have good news. If you are familiar with the command lines that you use to deal with your files and directories on your local drive, then it's pretty much the same commands here because it's a standard. It's called POSIX. It's called POSIX, right? So let me just check. If I show you this ls, cat, rm, mkdir, who understands these things? Most of you have seen them, right? This is what you type on your laptop. So ls lists the directory contents. It's a list of files in the working directory. cat will display on your screen the content of a text file, right? So that's what cat does. rm means remove directory. So it means that dir file will get deleted. And mkdir is make directory. So it creates a directory. But basically, these commands, ls, cat, rm, mkdir, you can learn them for HDFS if you don't know them, but it will not be only for HDFS. If you learn them, you will also know them for your own laptop on your local hard drive. So I strongly encourage you to learn these basic commands because this is really something that can be very useful. A lot of people connect to data centers via terminals rather than user interface, and that can be quite handy. All right. And how, so of course, this is if I work on the file system for existing files, right? But how do you, for example, upload files? Well, there is a command, and that one is not a POSIX command, that doesn't exist locally. It's called copy from local. Copy from local, if you type it on your laptop, you can specify the local file. So this is what you have on your laptop, and then where you want to put it in the HDFS cluster, right, in the hierarchy. And the other way around is copy to local. So this is the HDFS file you want to read, and you want to copy it back to your local file. Big word of warning, if this user Hadoop file is 1 petabyte in size, which can be because it was written, you know, in another way to the network, and you try to download that to your laptop, do not be surprised if your laptop crashes, right? You should really make sure if you download something from HDFS, check the size first. That it actually fits on your laptop. But uploading is no problem at all. If it fits on your laptop, then it will fit on HDFS. All right. I think that's all I wanted to say. Yeah, so this is the case where the client is your laptop, right? As I said earlier, the client can also be one of the data nodes. It can be one of the nodes in the data center. That happens if you use MapReduce or Spark. But the client can also be your laptop. In which case you can upload and download. Okay, and finally, 2 pieces of information that you know that exists. Basically, there is a library called Apache Flume that is basically allowing you to collect logs into HDFS. So you just have sensors or whatever, it just flushes everything constantly to HDFS as logs. And there is Apache Scoop that is able to copy over data from a relational database to HDFS, right? If you want to go ahead and use MapReduce and Spark and so on. All right, and I'm done actually. Oh no, I'm not quite done, but there's nothing much left, right? So this is just to make you aware of terminology that you shouldn't be surprised if the words are different. So in Google File System, which is the original, they don't say name node, they say master. They don't say data node, they say chunk server. They don't say block, they say chunk. They don't say namespace image or file system image, they say checkpoint image. They don't say edit log, they say operation log, and so on and so on and so on. Does it really matter? Not really. These are just words, right? But just be aware, if you understand how this works, no matter what other technology you're going to use, you will easily find the words that corresponds to what you already know. Okay. Also, something I warned you about is that the exact size of a block might differ. I mean, the original DFS, they didn't use 128 megabytes, they used 64. Azure now seems to like 4 gigabytes as a block size. But again, it's the order of magnitude that matters the most. If you tell me the block size is 1 kilobyte, then we'll have a problem because that is just going to be too slow. If you tell me the block size is 1 petabyte, then that also doesn't work, right? So it's the order of magnitudes, okay? And these are papers. There is, if you want, there's official documentation. There's the GFS paper, but I think there's also an HDFS paper. You can read either. I think the mandatory reading is the actual textbook where there is everything. And if you're interested in reading the HDFS paper or the GFS paper, go ahead. You know, that can be interesting for you. The Java API. If you want, I mean, I don't think we'll even use it. Even in the exercises, we don't use it, right? So this is just for the advanced users who would be interested to use Java. Then there is an API that you can use to connect to HDFS. But if you're just playing around, this is what I recommend. This is probably the easiest way of, you know, just playing with commands and so on. The one thing you should notice here is that it's going to be slow. This is the one thing I want you to notice. You press enter after this, it's going to take 1 or 2 seconds. 1 or 2 seconds. If you do the same on your laptop without Hadoop FS, it's going to take milliseconds. It's instant. So you really have to feel that difference that when you access a cluster over a network, there is latency. These 1-2 seconds, this is latency that you experience, and it's going to be slow. Okay. So we'll stop here for the Hadoop distributed file system lecture and jump to syntax. But before that, I want to give you an opportunity to ask any question, anything that is unclear. Nobody in the lecture hall. What about Zoom? Do we have any? Okay. So I assume it's all clear to you. Even if it's not, I mean, read the textbook. You will have another written explanation of what I just told you in the textbook. You can read the papers. You can ask questions on the, I think it's called Moodle Overflow, right? This new plugin that we have in Moodle. So you can ask questions there. You can write us emails. Do not hesitate, and we will be here to help if there is anything. All right, so I'm wrapping up HDFS, and I'll see you on the other side with the syntax lecture.